Today we have Unit 1, Lesson 1, Chemical Combination. Before starting the lesson, we have to know what is the lesson about. The lesson is about number 1, properties of metals and nonmetals. Number 2, types of chemical bonds. Number 3, types of covalent bonds. And here I want to start with the electronic configuration of metals and nonmetals, as you have studied before in Prep 1 in the first term. You have studied before that elements can be classified according to their properties and electronic configuration into metals, nonmetals, and noble gases. And here we have the graphic organizer shows elements and their classifications. Elements can be classified according to their properties and electronic configuration into metals, nonmetals, and noble gases. So we have to study each one: metals, nonmetals, and noble gases. Okay, let's start with metals. Metals are the elements which have less than 4 electrons in the outermost energy level. I mean, if you have an atom of metal, and if you know the atomic number and the mass number of that element, you can draw the electronic configuration of that atom. And if you draw the electronic configuration of that atom, it will end with 1, 2, 3, 4, 5, 6, 7, and 8. If it ends with 1, 2, and 3, it will be metals. And if it ends with 5, 6, 7, it will be non-metals. Here we have non-metals are elements which have more than 4 electrons in the outermost energy level. And here I mean 5, 6, and 7. But if they have 8, they will be classified as noble gases or inert gases. Inert gases are elements in which the outermost electron shells are completely filled with electrons, so they do not participate in any chemical combination in ordinary conditions. I will explain again. Here we have elements. Elements can be classified according to their properties and their electronic configuration into metals, nonmetals, and noble gases. If you draw the atom, you will see the outermost energy level. If it contains less than 4, I mean 1, 2, or 3, they will be classified as metals. And if they have more than 4 electrons, I mean 5, 6, and 7, they will be nonmetals. And if they have 8, they will be noble gases. So metals are elements which have less than 4 electrons in the outermost energy level. And nonmetals are elements which have more than 4 electrons in the outermost energy level. And the noble gases, they are elements in which the outermost electron shells are completely filled with electron. Okay, now what will happen? What will happen when an atom loses or gains electron? They will form what is known as, or which is known as, positive ion or negative ion. So here we have to know what is meant by positive ion. It is the atom which loses 1 electron or more during the chemical reaction. Here I mean metals, because metals will lose 1 electron or more. So metals form positive ions during the chemical reaction, and negative ion is the atom which gains 1 electron or more during the chemical reaction. And here I mean nonmetals, because nonmetals tend to gain 1 electron or more during the chemical reaction. They tend to gain. If metals lose 1 electron or more, they will form positive ion. And if nonmetals gain 1 electron or more, they will form negative ion. And what will happen if we have the two types of ions, positive ion and a negative ion? A positive ion and a negative ion, they will form ionic bond. So ionic bond is a bond resulting from the electric attraction between a positive ion and a negative ion. And here we will see example of ionic bond in the lesson later. Now let's study the other type of bond, because we have two types of bond, ionic bond and covalent bond. Covalent bond is a type of bonds that occurs between two non-metal atoms by sharing the electrons. And we have three types of covalent bond. Covalent bond may be single or double or triple according to the number of electrons. We will see many examples of covalent bond. Number one, single covalent bond. In single covalent bond, we will see that each atom will share the other atom with 1 electron. So it can be defined as, it is the bond which arises between two non-metal atoms where each atom shares the other atom with 1 electron. And it is represented by only a line joining the two atoms. Double covalent bond is the bond which arises between two non-metal atoms where each atom shares the other atom with 2 electrons. And it is represented by 2 lines joining the 2 atoms. And we will see example of double covalent bond, or an example for double covalent bond, which is O2. And here the triple covalent bond is the bond which arises between two non-metal atoms where each one shares the other atom with 3 electrons. In triple covalent bond, each atom shares the other atom with 3 electrons. And it is represented by 3 lines above each other, something like congruent in math. You know the mark of congruent in math? Okay. Now let's starting. As we said before, elements are metals, non-metals, or noble gases. Yes, chemical bonds, it may be ionic bond or covalent bond. And here we have the graphic organizer for types of covalent bond: single covalent bond, double covalent bond, and triple covalent bond. As we said before, in single covalent bond, each atom shares the other atom with only 1 electron. And in double covalent bond, each atom shares another atom with 2 electrons. And in triple covalent bond, each atom shares the other atom with 3 electrons. And here we have in our text the properties of metals. Number 1, they are solids except mercury, which is the only liquid metallic element. And here I mean all metals are solids. All metals around us are solids except mercury, which is the only liquid metallic element. Number 2, they have metallic luster, or I mean they are shiny like gold. Number 3, they are good conductors of heat and electricity like copper. So that's why we use copper in making electric wires. And here we have a question, give reason for copper is used in making electric wires. The answer, it will be because copper is good conductor of electricity. Okay, number 4, they are malleable and ductile. I mean they can be shaped. During the chemical reaction, atoms of metal tend to lose their outermost electrons to other atoms and change into positive ions, which carry a number of positive charges equal to the given electrons. And here we have 3 examples show how metals lose their outermost energy electrons and change positive ions. Let's start with sodium. Na1123. Sodium Na1123. You can draw the electronic configuration of sodium by knowing 2 numbers: atomic number, which is 11, and mass number, which is 23. And here we have a neutral sodium atom, Na. It contains 11 electrons, 11 protons, and 12 neutrons. Here the electronic configuration of sodium: 2, 8, and 1. First energy level takes 2, as you have studied before in prep 1 in the first term, and the second energy level takes 8, and the third energy level, here we have 1 electron in the third energy level. During the chemical reaction, the sodium atom Na loses, here we have sodium atom, and here we have sodium ion. During the chemical reaction, sodium atom Na loses 1 electron and changes into a positive ion, which carries 1 positive charge. Positive sodium ion, Na positive. During a chemical reaction, it loses the electron in the outermost energy level to form positive ion, 2, 8. And here we have in sodium ion, it contains 10 electrons, 11 protons, and 12 neutrons. Another example, Mg, magnesium. Magnesium Mg1224. The atomic configuration of, or electronic configuration of magnesium by knowing mass number and atomic number. Atomic number is 12, mass number is 24. So neutral magnesium atom Mg, it contains 12 electrons and 12 protons and 12 neutrons. So if we want to draw the electronic configuration of magnesium, it will be 2, 8, and 2. During the chemical reaction, the magnesium atom Mg loses 2 electrons and changes into a positive Mg, positive 2, which carries 2 positive charge. And here we have positive magnesium ion. It loses 2 electrons from the outermost energy level to be more stable. Positive magnesium ion, Mg positive 2, It contains 10 electrons, 12 protons, and 12 neutrons. And here we wrote Mg positive 2 because it loses 2 electrons. And here we have another example, aluminum Al1327, neutral aluminum atom Al, atomic number is 13, so the number of protons will be 13. The number of electrons equal the number of protons, 13, and by knowing mass number we can know the number of neutrons, which is 14. And here if we want to draw the electronic configuration of aluminum, it will be 2, 8, 3. During the chemical reaction, aluminum atom Al loses 3 electrons from the outermost energy level, and it changes into a positive Al positive 3, which carries 3 positive charges. Positive aluminum atom Al positive 3, positive aluminum ion, it contains 10 electrons, 13 protons, and 14 neutrons. Yes, now we have the properties of nonmetals. Number 1, they are solids and gases, except bromine, Br, which is the only liquid nonmetallic element. I mean all nonmetals are solids and gases. Around us, all nonmetals are solid and gases except bromine only, which is the only liquid nonmetallic element. Number 2, they have no luster. I mean they are not shiny, like sulfur. Number 3, they are bad conductors of heat and electricity, except graphite or carbon, which is a good conductor of electricity. Number 4, they are not malleable nor ductile. I mean they cannot be shaped. During the chemical reaction, atoms of non-metals tend to gain electrons from other atoms to complete their outermost energy level and changes into negative ions, which carry a number of negative charges equal to the number of the gained electrons. And we will see many examples of nonmetals. Here we have 3 examples. The first example is chlorine Cl1735. In neutral chlorine atom Cl, it contains 17 electrons, 17 protons, and 18 neutrons. And if we want to draw the electronic configuration, it will be 2, 8, and 7. During the chemical reaction, the chlorine atom gains 1 electron and it changes into negative ion, Cl negative, which carries 1 negative charge. Here above the arrow, it gains 1 electron and form 2, 8, and 8. Negative chlorine ion, Cl negative, it contains 18 electrons, 17 protons, and 18 neutrons. Here we have another example, which is oxygen O8 2, 6. It contains 8 electrons, 8 protons, and 8 neutrons. During the chemical reaction, oxygen atom gains 2 electrons and change into negative ion O negative 2, which carries 2 negative charge. Here we have negative oxygen ion O negative 2. It contains 10 electrons, 8 protons, and 8 neutrons. And as you see, here we have 10 electrons and 8 protons. The number of electrons is more than the number of protons by 2. So here we must write 2. Now I have a table which is about inert gases or noble gases, and I want you to complete the electronic configuration and draw the electronic configuration of some inert gases. Here we have the atom of the inert gas or noble gas, He24, number of electrons 2, number of protons 2, number of neutrons 2. The second is Ne, neon, Ne 1020, number of electrons 10, number of protons 10, and the number of neutrons is also 10. Argon, Ar 1836, number of electrons 18, number of protons 18, and the number of neutrons is 18. Okay, now let us see how is the ionic bond formed. Ionic bond is formed by 3 steps. Number 1, metal atom loses electron and changes into a positive ion. Number 2, non-metal atom gains the electrons lost from metal atom and it changes into a negative ion. And number 3, a strong electrostatic attraction between positive and negative ions occurs through the ionic bond. And we will see example for an ionic bond to show how is the ionic bond formed. Here we have example number 1, formation of sodium chloride table salt molecule NaCl. It's formed by 3 steps. Number 1, sodium atom Na1123 loses 1 electron and it changes into a positive ion. Here we have neutral sodium atom 2, 8 and 1 Na11. It loses 1 electron to be 2 and 8. And the chlorine, which is non-metal, Cl1735, gains this electron which is lost by sodium atom and changes into a negative ion, Cl, negative. Here we have the electronic configuration of Cl1735, which is 2, 8 and 7. It gains 1 electron to be 2, 8 and 8. A strong ionic bond is formed due to electric attraction or electrostatic attraction between positive sodium ion Na positive and the negative chlorine ion Cl negative, forming an ionic bond or ionic molecule, NaCl, table salt. And here we have the third step, which is represented by electrostatic attraction between positive ion and negative ion. Here we have many examples of covalent bond. The 3 types of covalent bond: single covalent bond, double covalent bond, and triple covalent bond. Number 1, single covalent bond. Hydrogen molecule, hydrogen atom which is non-metal, H1, joins another one, hydrogen atom which is non-metal, H1, to form H2. And here each hydrogen atom shares with 1 electron to complete its outermost shell K level. K level is completely filled with 2 electrons. So each one will share the other with 2 electrons and become more stable. In single covalent bond, each atom shares the other with 1, and here in the example, each hydrogen atom shares with 1 electron to complete its outermost shell K level. with 2 electrons and it becomes more stable. Here we have another example, which is water. Oxygen O816, it needs 2 electrons to complete its outermost energy level. So oxygen atom shares with 2 hydrogen atoms by 2 electrons, one for each hydrogen atom to complete its outermost shell and form H2O. Here we have hydrogen atom which needs 1 electron to be 2 electrons in the outermost energy level, and here we have another hydrogen atom which needs 1 electron to form 2 electrons in the outermost energy level, and here we have in the middle oxygen atom which needs 2 electrons. So oxygen atom shares the 2 hydrogen atom by 2 electrons, one for each one. The second type, which is double covalent bond. Here we have the example of double covalent bond. 2 atoms of oxygen O816. The first energy level has 2. The second energy level has 6 electrons. Another oxygen, 2 and 6. Each one needs 2 electrons to complete its outermost energy level with 8. So they share each other with 2 electrons, as you see in the electronic configuration of O2. Here we have 4 electrons. Each one shares with 2 to complete the outermost energy level. And the last example, which is triple covalent bond, N2. Here in nitrogen atom, N7, 2 and 5. It joins another nitrogen atom, N7, 2 and 5. Each one needs 3 electrons to complete the outermost energy level with 8. So they share each other with 3 electrons, as you see in nitrogen molecule. The first energy level takes 2 in each one, and in the second energy level each one shares the other with 3 electrons. And you see here we have 6 electrons, 3 electrons from the first atom and 3 electrons from the second atom. Each nitrogen atom shares with 3 electrons to complete its outermost shell with 8 electrons, and it becomes more stable. Now we have in our lessons many types of bond: ionic bond and covalent bond. And in covalent bond you have 3 types, which are single, double and triple, and you have to study examples for each one, starting by an ionic bond, ending by the triple covalent bond. I hope you understand the lesson very well and try to answer questions on lesson 1 in our binder for the next session.